You ever stop and think about how your body, this, incredibly complex collection of cells, just knows how to fight off some invisible invader it's never even seen before? It is an absolutely amazing biological marvel. So today, we're going to dive deep into our body's defense system and explore how science basically figured out how to give it a personal trainer. Let's get right into it.
All right, so here's the game plan. We're going to start with the two basic ways our bodies build defenses. Then we'll jump into the scientific revolution that taught us how to train our immunity on purpose. From there, we'll explore the modern tools we use today and even get a little sneak peek into the future of engineered immune therapies. And finally, we'll talk about why your personal immunity is actually way bigger than just you.
Okay, let's get right to the heart of it. Your immune system isn't just one single thing. It's this super dynamic system that's constantly learning and adapting, and it really has two main ways of getting the job done.
So this is the fundamental question, right? How does it get the know-how to fight? Well, it turns out it can either build the weapons all by itself, or it can borrow them from someone else. So first up, we have active immunity. The best way to think about this is like your body's own personal training program. When you get exposed to some kind of invader, an antigen, your immune system, it just goes to work. It learns the enemy's weaknesses, and it starts creating these custom-built defenses, antibodies and memory cells, so it is absolutely ready for the next time. This is immunity that's earned, not just given.
And then on the flip side, you've got passive immunity. This is kind of like being handed a ready-made shield right before a battle. You didn't forge it yourself, but hey, it works immediately. The classic example of this is when a mother passes IgG antibodies to her fetus through the placenta. That baby is literally born with borrowed protection.
Now, when you put them side by side like this, you really see the crucial trade-off. Active immunity, it takes a while to build up, right? But the payoff is huge. It creates long-term immunologic memory. Passive immunity, though, is instant. It gives you protection right now, but it's temporary. It's a short-lived shield, and once it's gone, there's no memory of the fight. So you've got this fascinating difference between lasting knowledge and a quick fix.
So understanding these two systems is one thing, but figuring out how to trigger our body's personal training without actually making us sick? Whoa, that was a revolution. So how on earth did scientists first crack that code?
Well, the key figure you have to know here is Louis Pasteur. His work was just groundbreaking, and it was all built on this one single powerful idea, attenuation. So, what does that actually mean?
Attenuation is this genius process of taking a really harmful pathogen and just weakening it. You're basically pulling its punches so it can't cause any real disease. Think of it like a sparring partner for your immune system. It looks and acts enough like the real enemy to trigger a full-on training session, but it just can't land a knockout blow. Pretty clever, right?
And this is exactly why attenuation was such a game changer. Because that weakened pathogen can still replicate just a little bit in the body, it kicks off a much bigger, more comprehensive defense. It's not just about making antibodies, that's what we call humoral immunity. It also wakes up our cellular fighters, the T cells. So you get this powerful, two-pronged attack. Pasteur's breakthrough really kicked the door wide open. And since then, scientists have developed this entire toolkit of different ways to train our immune system. Yeah, it is not just about attenuation anymore. We've come a long way. So check out some of these modern strategies. We still use the classic attenuated or weakened pathogens, but now we've got these other brilliant methods. Recombinant vaccines, which were first used for hepatitis B all the way back in 1986, they just use a tiny piece of the pathogen's protein. And then you have toxoid vaccines, which use an inactivated toxin. It's totally harmless, but your immune system still recognizes it. Each one of these is just a different tool for a different job. Okay, now we are entering a whole new era. Because what if instead of just preventing disease, we could actively engineer our immune system to go after diseases like cancer that are already in the body? Well, that's not science fiction anymore. That's where we're headed.
So one of the most exciting frontiers here is something called adaptive immunotherapy. Instead of just teaching your body, this approach involves transferring these powerful, supercharged immune cells directly into a patient. It's like calling in a team of elite cellular special forces to give the body's own defenses a massive boost.
Now, to build these therapies, scientists had to get really, really clever. Take chimeric antibodies, for example. They figured out how to basically stitch together the part of a mouse antibody that does the targeting with the main body of a human antibody. This little trick makes the engineered antibody way less likely to be seen as foreign and get rejected. This bit of bioengineering was absolutely critical, and it's the key that unlocked even more advanced therapies.
And all of this comes together in something truly incredible called CAR T-cell therapy. Here's how it works, step by step. First, scientists pick out an antibody fragment that's designed to do one thing: find and lock onto a cancer cell. Next, they genetically link that targeting piece to the engine of a T-cell, the part that tells it to attack. Then, to really soup it up, they add what's called a co-stimulatory molecule. Think of it like adding a turbocharger. Finally, they take a patient's very own T-cells out, engineer them with this brand new powerful receptor, and then put them back into the body. What you get is an army of precision-guided cancer-killing machines. And the results? They've been nothing short of revolutionary. For certain blood cancers that were basically a death sentence, CAR T therapy has offered a real shot at a cure. It's a total paradigm shift.
So we've gone from the fundamentals inside a single person all the way to these incredibly advanced personalized therapies. But you know what? The story of immunity isn't just about one individual. It's about all of us.
It's a simple question, right? But the answer has these huge implications for public health. Does your personal ability to fight off a disease or your decision to get vaccinated, does that actually impact the people around you?
And the answer is a huge, resounding yes. This is the whole idea behind herd, or community immunity. See, when enough people in a population are immune to a disease, they create a kind of protective firewall. The pathogen tries to spread, but it just keeps hitting dead ends. It's starved of new people to infect. And this protects the most vulnerable people in our society: newborns, the elderly, and anyone whose immune system is too weak for a vaccine.
Of course, immunity is not a one-size-fits-all deal. How well a person responds to a vaccine can really vary based on these key factors. An older person's immune system, for example, might not build as strong of a memory. Someone who's already immunocompromised might not respond much at all. And even the type and dose of the vaccine are carefully designed to get the best response. And this variability is precisely why that community shield is so vital. So, what a journey, huh? We've gone from borrowed shields to personal training, all the way to engineering our own cellular assassins. We've learned how to protect not just ourselves, but our entire community. So the final question I want to leave you with is this: as our mastery of this incredible system grows, what are the next great challenges, from autoimmune diseases to the next pandemic, that we could finally conquer?